All right, let's try this next example here. This one is a little bit more complicated. As you can see, it is an equation, not just a polynomial, so we do have to solve the polynomial equation. It's actually two polynomials equal to each other. And remember, to solve a polynomial, the first thing we need to do is set one side equal to 0, get a 0 somewhere. And so I like to use the right side, although again, it doesn't matter. And so I'm going to subtract the 20x from both sides, and I'm going to add 40 to both sides. I'm going to go ahead and do that all in one step. It doesn't really matter if you do it in 2 steps or 1, it just saves me from writing this down twice. Everything will drop off the right side, but notice on the left side, there are no like terms, okay? So I can't really combine anything. So I'm going to have 5x to the third minus 10x squared minus 20x plus 40, and then the entire right side just becomes 0. Okay, so it equals 0. Okay, so that's step 1. Step 2, factor the remaining polynomial. So there's a polynomial on the other side. We need to factor that thing. It's of course got 4 terms. Remember, the first thing we always do when factoring is to look for a greatest common factor, and this one has a factor of 5 in common. So I'm going to go ahead and pull that out. So I get 5 times x cubed minus 2x squared minus 4x plus 8 equals 0. Okay? Don't forget the equals 0. I see a lot of people leave that off, and then all of a sudden they get to the end, they're factored, and then they forget to move forward. So this is an equation all the way through. Now I've got 4 terms, and remember, the only way other than a GCF to deal with 4 terms is using the grouping method. So we're going to group the first 2 terms and the last 2 terms together. I'm going to use a set of brackets so I can keep my 5 involved as I work this out. I'm going to pull out an x squared from the first 2 terms. Now I'll have an x minus 2 left over. Here I'm going to pull out a 4. They have a common 4. But again, I want the signs to match up with the current set of parentheses I have in the first term. So I need positive, negative. Here I have negative, positive, so I have to switch the sign. So I'm going to pull out a negative 4 in order to switch the sign. That'll give me a positive x and a negative 2. I have to switch both of those signs. Of course, that equals 0. And then my final factored form for this original 4-term polynomial will include the x minus 2 that is common. It's a common binomial. And then the remaining factors of x squared minus 4. Now notice I left off the brackets because once I get to this point, I'm only multiplying the 3 factors together here. And so this multiplication, the multiplication can be scrambled in any order. I don't need the brackets. They were just separating the 5 off from everything else. Set that equal to 0. Now I'm actually not quite done yet, because the x squared minus 4 is still factorable. It's a difference of squares. So I can continue with this, x minus 2. Then the x minus 4, remember, factors into conjugates. There's going to be an x plus 2 and an x minus 2. If you'll notice, though, I have a repeated factor of x minus 2. It's kind of an interesting situation here. That repeated factor I could bring together and call it x minus 2 squared, right? I could do that. I don't have to. But when I set these factors equal to 0, there's going to be redundancy. I'm going to be solving the same thing. So I'm going to leave it. I'm going to leave it as is. But I don't need to set both of those x minus 2's equal to 0. Again, if I set one of them equal to 0, the other one will be 0. So I really don't have to do that once. So we're in factored form. And maybe I will group them together just so you can see what it looks like. So I could group those two, multiply them together, and just get a square there. Again, that doesn't really matter. All I need to do is set the x minus 2 equal to 0 once. Now notice the 5 is an extra factor, and I said we do need to set each factor equal to 0. The problem is if I have a constant out here, this constant can't be 0, right? Now if it's 5x, if there's an x attached to it, I could set that equal to 0 because there's a variable involved. But here, the number 5 itself cannot equal 0, and so we don't have to worry about that. As long as one of the other two factors is 0, the whole thing will zero out. So the 5 is just sort of an additional constant that's multiplying to 0. It doesn't matter. So really all I need to do to solve or to set the factors equal to 0 is make x plus 2 equal to 0 and x minus 2 equal to 0. Those are the only two factors we really need to deal with. Remember the other x minus 2, there's a second x minus 2 in there, but it's going to give us the same answer. So now I solve these. I get a negative 2. And I'm going to get a positive 2. So there's two answers, positive 2 and negative 2. And so, let's see, my solution set is just going to be negative 2 and positive 2. Okay? And it's just occurring to me now, I mentioned in the last video, I think it was the last video, where I said this is the first time we'll be seeing two solutions to an equation, but that's not true. When we dealt with absolute value equations, we saw two answers. I'm just remembering that. So this is actually the second time we'll be seeing two possible solutions to an equation, okay? It's the first time we'll be seeing more than two, I suppose. Okay, so that's a neat example. It's got a lot of things in it. It's quite a bit longer problem. The factoring itself was quite a bit longer, and then there's a lot to set equal to 0 there. So that's kind of a neat problem.